Here is a numerical type question. Work through the numbers carefully. Let us solve it step by step. Let us first understand the key concept here. Acidic groups are functional groups that can donate a proton, H+. The most common acidic groups in amino acids are carboxylic acid groups, -CoO, and the conjugate acid of the amino group, NH3+. Moving on to the next step. Identify the structure. This amino acid is shown in its zwitterionic partially ionized form. The molecule is glutamic acid, or a related structure displayed as NH3 plus CH CO2 CH2 CH2 CO2H. Moving on to the next step. Identify all potentially acidic groups in the parent, unionized, amino acid. The alpha carboxyl group, shown here as CO2, already deprotonated in this representation, but it is an acidic group CoO in neutral form. The side chain carboxyl group, shown as CO2H, terminal CoO, which is an acidic group. The alpha-amino group, shown as NH3+, which is also acidic, can donate a proton to give NH2, but in standard classification for amino acid acidic groups, the question focuses on CoO-type groups. And for the final step, count acidic groups. In the context of this question, the two carboxylic acid groups, alpha-CoO and the side chain CoO, are counted as the acidic groups. Both CO2- and CO2H represent carboxylate carboxylic acid groups. There are two such groups total. The NH3+ group is the acidic group of the ammonium type, but in the typical classification used here, the question counts carboxylic acid -CoO groups as the acidic groups, giving a total of 2. Why not 1 or 3? There is only one terminal, CO2H visible, but the alpha CO2- is also a carboxylic acid group, deprotonated form, so both count. That gives 2, not 1. Including NH3+ would give 3, but the standard answer counts only the carboxylic acid type acidic groups. Therefore, the correct answer is 2. Therefore, the correct answer is 2.